We are going to start our chapter on similarity. So we're going to start with discussing similar triangles. The objectives of this lesson for 13.1 is to identify and illustrate basic similarity postulates. We're going to look at the side-side-side similarity theorem, the side-angle-side similarity theorem, and we're going to apply those postulates and theorems to pairs of triangles that are similar. First, we'll talk about what does it mean to be similar. So first of all, this symbol right here is the similar symbol. So notice that it doesn't look like the congruent sign. The congruent sign had an equal sign and then that mark on the top of the equal sign. So this doesn't have the equal sign. So this does not mean congruent. So congruent meant that the measure was the same. Similar does not mean that. Similar does not necessarily mean that the measurements are the same. What it means is that the proportions are the same. So again, this is what it looks like for congruence, okay? And so for similarity, it means that the proportions are congruent. Not necessarily that the actual measurements are congruent, but the proportions of the measurements are congruent. So for example, if we have a triangle ABC that is similar to triangle XYZ, then that means that angle A is congruent to angle X, angle B is congruent to angle Y, angle C is congruent to angle Z, and these proportions hold true. So again, the angles are going to be the same, so the angles have to be congruent. So A has to be congruent to X, B has to be congruent to Y, and C has to be congruent to Z. So order matters. Those angles are going to be congruent. Now, the sides are not going to be congruent, but the proportions of the sides are going to be congruent. So for example, the side that is between X and Y over the side that's between A and B. So again, the side that's between X and Y over side AB is equal to the side between Y and Z over the side BC. So the side between B and C. So again, it's just a proportion. So you have this ratio. So you have the ratio of this side to this side has to be equal to this side over this side, which also has to be equal to the last side over the corresponding side on the other triangle. So all of these sides are corresponding to each other based on what angles they're in between. Postulates that help us prove similarity. There's the angle-angle similarity postulate. It says if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. They're not congruent, they are similar. So being similar means that all the angles are the same, but the sides are not congruent. The proportions of the sides, the ratios of the sides are equal to each other. So the angle-angle similarity postulate lets us say that two triangles are similar if only two pairs of corresponding angles are known to be congruent. Our theorem that we're going to look at is the side-side-side theorem, and it says that if three sides of one triangle are proportional, so not equal, not congruent, but proportional to the corresponding three sides of another triangle, then the triangles are similar. Then you have the side-angle-side similarity theorem, and it says if two sides of one triangle are proportional to the corresponding two sides of another triangle, and the included angles between the sides are congruent, then the triangles are similar. So it is important to know that similarity is an equivalence relation. And if you're like, oh, what does that mean again? What's equivalence? That's reflexive, symmetric, and transitive. So that is saying that triangle A is similar to triangle A. That's what reflexive means. If you say symmetric, that means that if triangle A is similar to triangle B, then triangle B is similar to triangle A. Transitive means that if you have triangle A is similar to triangle B, and triangle B is similar to triangle C, therefore triangle A has to be similar to triangle C, so it transfers. Alright, so that's our introduction to some similarity. We need to try some of those problems and see if we can identify similar triangles, and we can see if we can identify the proportions correctly.